Hi everyone, this is day 9 of the A2 Economics Division Challenge, and today we are doing the three sector model, which is basically government expenditure also included in the model. In a three sector model, we're looking at closed economy with government, which means now we have the government sector as well. What is government expenditure? We say government expenditure on goods and services like education, hospital, and public and merit goods, which is financed through tax revenue. So in our model, what we are doing now is introducing an important sector, which is government. When government expenditure is included here, we will see how government expenditure can change, which can result in GDP of an economy to change as well. Before we talk about that, about how the change in government expenditure can change GDP, we want to talk about government expenditure relationship with national income. We say government expenditure is autonomous, which means as your GDP go up, government expenditure may stay constant. So in a Keynesian model, we treat government expenditure as not dependent. Let me write this: not dependent on Y. So even though your GDP may go up from, let's say, Y naught to Y1, the government expenditure G may not change. So we assume the government expenditure is autonomous and not a function of Y. And let's assume government expenditure in our model to be 170. So even though my GDP may change, my government expenditure may not. The government decision to change, let's say, government expenditure can happen, but if it does happen, it will happen for all level of income. So something like this, where let's say G0 to G1, government expenditure may change, where from, let's say, 170 to 270, and if this changes, it changes for all level of income. On the other hand, the money that we sort of get to finance this government expenditure is what we call tax revenue. The tax revenue basically in our model, in a Keynesian model, is basically induced. Induced means a function of y. So for us, tax revenue is equal to small t times y, where small t is the tax rate. Now, government decides at the beginning of the period what the tax rate will be. Let's say government decides to have a tax rate of 10%. So if tax rate small t is 10%, then my equation becomes t is equal to 0.1 y. From here, we can find out what we call budget balance. What is budget balance? Budget balance is simply t minus g. If t minus g is greater than 0, we say this is a budget surplus. Why? Because there is government revenue is more than the government expenditure. Now, remember this, guys, that taxation is a withdrawal in the circular flow of income, while government expenditure is an injection. Similarly, if t minus g is equal to 0, we call it balanced budget. And if t minus g is less than 0, we call it budget deficit. So in our model, what we are doing is this, that now we are putting in our AE, which is equal to C plus I plus G, but we're also doing something else. In our withdrawal function, which was previously only saving, I'm going to put one more withdrawal, which is taxation. And in my injection function, previously, which was only I, I'm going to put another injection, which is I plus G. So government expenditure becomes an injection, and taxation becomes what we call a withdrawal. And if t minus g is greater than 0, this means the government is although earning budget surplus, but there are more withdrawals happening than injection, and that's why sometimes t minus g greater than 0 is called budget surplus, but also called net withdrawals. So after taking into account the government expenditure, we are withdrawing more than injecting. Similarly, when we look at a balanced budget, there is no withdrawal or injection happening. The budget is balanced. But when you have a budget deficit, we call it net injections. More money coming in than going out. When we introduce taxation in our model, we will now need to change our MPC and MPS. So I want to explain before and after kind of a scenario. So in our two-sector model, this is how things look like. So let me write this, two-sector. In our two-sector model, we had change in Y, let's say, of $1. Then your MPC was basically 0.8 and MPS was 0.2. Now this implies that if you have an extra dollar of income, 0.8 of it will be consumed and 0.2 of it will be saved. Now in this two-sector model, remember, there is no taxation, there is no government expenditure, so there is no withdrawal. The only withdrawal that is happening is saving. So that's your two-sector model. In a three-sector model, on the other hand, we have both taxation and government expenditure happening. So if there is an extra dollar given to us, so if change in Y is $1, first thing that happens is that government takes 0.1 of it away. If the tax rate is 0.1, which is also called sometimes MRT, marginal rate of taxation, or sometimes even MPT, marginal propensity or tendency to tax, is 0.1, then we are left with a disposable income, change in YD, disposable income of 0.9. Now of this 0.9, if I say now the MPC is 0.8, this means that now my new MPC after tax, so MPC dash, which is after tax, will be 0.9 times 0.8. So I'm now not given a dollar, I'm not given a dollar, I'm giving 0.9 of a dollar. So 0.9 times 0.8 is basically 0.72. Similarly, when you go look at our MPS now, what is happening with MPS? Now my new MPS will be 0.9, which is what I'm left with, and not a dollar. 0.9 times 0.2, which will be 0.18. So basically, when we are in a three-sector model, we need to change our MPC and MPS to account for the tax rate. So if my tax rate is, for example, 0.1, I'm left with 0.9, so I'm going to adjust my MPC and MPS. In other words, we can find out after tax sort of equation. So MPC after tax will be old MPC times 1 minus T. Similarly, MPS will be old MPS times 1 minus T. So that's an adjustment we need to do to make sure we get after tax sort of consumption and saving. Now look at this, guys. Previously MPC plus MPS, MPC plus MPS was equal to 1, and now even new MPC dash, which is after tax, plus new MPS dash plus your tax rate, let's call it MPT, is equal to 1, which means basically 0.72 plus 0.18 plus 0.1 is equal to 1. And if this is the result, if the result is equal to 1, this means you've done the things right. Now let's change our equation from two sector to three sector. So in two sector, we had A is equal to C plus I plus G. Let me just write that here. On this side, A is equal to C plus I, while in three sector now I have A is equal to C plus I plus G. In two sector, C was 100 plus 0.8y. Now my new C will be 100 plus 0.72y. Remember, because my tax rate is 10%, so I've changed my MPC from MPC of 0.8 to 0.72. Now similarly, my saving was minus 100 plus 0.2y. My new saving function will become minus 100 plus 0.18y. Similarly, I have investment which is still 250, so I'm going to have the same investment here now, which is 250. My government expenditure I'm taking as 170, which is not to be found in the two sector, but in the three sector I have government expenditure of 170. But now I also have one more thing, which is taxes, and the tax rate is 0.1y. So my equation has now changed from two sector, let me write this here, from a two sector model to a 3-sector model. So things we need to remember is that from when we move from 2-sector to 3-sector, we need to incorporate our tax rate in our model. Now when you look at this equation, now my new AE becomes C plus I plus G, which is 100 plus 0.72y plus 250 plus 170 as my new equation, which means AE becomes in this case 100 plus 250 plus 170, which is equal to 520 plus 0.72y. So this becomes my new aggregate expenditure. Now let's see this in terms of a diagram. So my first step would be to draw A is equal to Y line, which is my income line. So I'm going to draw my A is equal to Y line, which is my income line, which is the 45-degree income line. Now this 520 plus 0.72y, I'm going to draw that here. 520 plus 0.72y will be my new equation for AE, which is 520 plus 0.72y, and I will find myself what we call the equilibrium income Y star. How do we find Y star? Well, we say AE is equal to Y is our first equation, and the second equation is AE is equal to 520 plus 0.72y. If I now equate this AE with Y, so Y becomes 520 plus 0.72y, which then becomes, if this 0.72y goes on the other side, 0.28y is equal to 520, or y is equal to 520 over 0.28, which is equal to 1857. So 1857. So I'm going to write this here, Y star is equal to 1857. Now this Y star should also come into my W and J equation as well. What is my withdrawal equation? My withdrawal equation now is simply S plus T. Now I have added T in my withdrawal as well. So now my new withdrawal equation will be minus 100 plus 0.18y. Remember, this is after tax, plus 0.1y, which means withdrawal becomes minus 100 plus 0.28y. Similarly, my injection equation, so I'm going to put this here, injection equation will become J is equal to I plus G. So J will become investment of 250 plus G is 170. So this becomes 250 plus 170 becomes your 420. So if I now solve this part of the equation, where first I'm going to draw my W. My W is like this. My withdrawal function is, for example, like this, where withdrawal is equal to a minus 100 plus 0.28y. That should equal injection J at this point. Let me draw my injections now. My injections will be like this, and my injection equation is basically 420, and the Y should be equal to 1857. Now I'm saying this, that A is equal to Y and W is equal to J should give us the same answer, where W is equal to J should give us the same answer. W is minus 100 plus 0.28y is equal to 420, which is J. Therefore 0.28y will be equal to 520, which means again I am getting the same answer of y is equal to 1857. So first of all, we need to understand this, that A is equal to Y and W is equal to J should give us the same answer if our calculations are right. Now, having found this, the next question we need to ask ourselves is, okay, what is the value of the multiplier? So in a 3-sector model, our multiplier will also change. Remember, multiplier's equation or multiplier's value, let me write this, multiplier is always equal to 1 over 1 minus MPC. Now, which is also in this now 3-sector model is going to be 1 over MPS plus MPT. Remember this, guys, when we were in a 2-sector, your MPC plus MPS was equal to 1. So the value of MPC was 1 minus MPS. But in a three-sector model, in a model where there is closed economy with government, my MPC plus MPS plus MPT, the tax rate, is equal to 1. So now my MPC will be 1 minus, or rather MPC will be 1 minus MPS plus MPT. So that's why MPS plus MPT, if I in fact rewrite this, I'm going to say MPS is equal to 1 minus MPC, which is exactly what we saw in a two-sector model, and here MPS plus MPT is equal to 1 minus MPC. So our two-sector multiplier was simply 1 minus MPC, 1 over 1 minus MPC, which was MPS, so that was 5. But now I have 1 over 1 minus MPC, which is MPS plus MPT. So my new value of multiplier will be 1 over MPS is 0.18 plus MPT is 0.1. Write this 0.1, and that makes this 1 over 0.28, which is, if I do the math, 1 over 0.28 is equal to 3.57. So if they give you a three-sector model and they say AE, change in AE is equal to 100, how much will be the change in Y? Your answer will be change in Y is equal to change in AE times multiplier, and our multiplier in this case will be 100 times 3.57, which means change in Y will be 357. So what we need to remember is this: not only our AE equation will change to C plus I plus G, our withdrawal equation will change to W is equal to S plus T, our injection will be changing to I plus G, but our multiplier will also be changing to 1 over MPS plus MPT. So this is basically, guys, our three-sector model. Now what we do in the next video, we'll be talking about our four-sector model where we introduce even X minus M.